Alright, lightning speed of chapter 10. There is one last thing to talk about, so tricky business, parametrics, double derivative. Gotta remember to divide by the XDC again. And length of a curve defined parametrically, the x to t squared plus dy to t squared into the square root, integrate over the bounds. Vectors, very much like parametrics. If you want to find how much something has traveled given a vector equation, well, it's the x dt squared plus dy dt squared into the square root integrated over the time span. Speed is that same thing, but at a single point. What else was special about vectors? Double derivative, you leave it in vector form. So if you see the word vector, you leave the x component where the x is, the y component where the y is. Polars, be able to type them in. Because a lot of you are uncomfortable with them, so it might help you to be able to use your calculator to see what's going on. You don't have to, but it's helpful. We did area yesterday. And to find dy dx, and you need to remember that y is the equation for r sine of theta, and x is the equation of r cosine of theta, which makes these derivatives yucky, because they will be some kind of product rule, and often product rule with a chain rule. Just makes them a mess, and whatever you get here, I recommend that you do not clean it up, and you just evaluate it wherever they asked. Because that pi over 2 is going to make sine or cosine, at least one of them go to 1 and one of them go to 0. Something nice should happen. But can we try the question that's actually here? It's asking us to find the area of the region that lies inside the circle, but outside the cardioid. So inside the circle and outside, don't know what a cardioid is? Well, it's the other equation that's there. There's a whole bunch of valid ways to do this. Anybody got a strategy? Yeah? No, you're stretching. Oh, some kind of strategy on how we're gonna find that, like, Batman shape area. Area of, not the whole circle, but half the circle minus the area. Okay. Okay, sure. An area of the circle with a radius of 1, pi r squared, so pi, but I only wanted half of that, so the area of that semicircle is pi minus, I didn't draw this for you guys yesterday, I should have. When we were in rectangular coordinates, we were finding the areas of lots of little rectangles. Now we're finding the area of lots of little pie slices. Okay, how do I find the area of the little pie slices for effectively the butt cheeks of the cardioid? From yesterday's things, ready? Yeah, never mind. Yeah.
Integrate like the cardioid, like the radius squared, and you integrate it from pi over 2.
So r squared, and r is 1 minus cosine theta And you said from where to where? How do you know the bounds?
I set 1 equal to 1 minus cosine theta.
So where does this equation and that equation, where they equal, which is where cosine is 0. Pi over 2 and 3 pi over 2, so you said to integrate the bounds where to where?
Pi over 2 and pi over 2.
Okay, careful. Pi over 2 to 3 pi over 2 is the wrong space. So this is where they intersect, but you need, this is why I'm like, maybe you need to know how to use this on the calculator, no, but it might be helpful.
So 3 pi over 2 is 0, or like 2 pi.
Okay, bunches of choices. If we do 3 pi over 2, well, that's not gonna work either. That's one possibility. So saying negative pi over 2 to positive pi over 2. There's a symmetry to this. Could I go from 0 to pi over 2 and just double it? And that's easier to type in. They should both work. So try on your calculator, see if you can get this. The hard thing is typing. Please make sure that on the quiz that you have on Friday that you write down the setup, because I believe a lot of you are gonna get the setup right, and you're gonna type it wrong. Yep.
Are we, like, for, it says pi is the area of the area of the circle?
Pi squared, so semicircle, you're right. I said it, but I didn't write it. Something like that. Answer keys that I write, I have all 3 of these written. If you had extra decimals, that's fine. If you just truncate, that's fine. If you round correctly, that's fine. If you round or truncate incorrectly, like pre-cal yesterday, they were like, oh, but it's a 0.49. I'm gonna round it up to like, it's almost a half, and that almost a half, they rounded up an extra 1 because they felt bad. Please teach that. Right, did you guys try typing it in? Did you get that answer? Okay. So yeah, the hard part is typing. So here is an actual AP question. For pullers, give it a try. They take about 10 or 15 minutes, and we have the weird schedule today, classes over a little early, but I'd like to give you guys time to do this, and then we'll talk about it. Because otherwise
It's the other, it's not,
okay. Can I see again, how many of you are taking the quiz early? And when? Tomorrow morning? Make sure I have copies of it. Just curious, how close are you guys to being done the first attempt? That was 11 minutes, 12? And rule of thumb is they should take about 15 each. So if you're 2/3 of the way, like on part C or something. Part A. It's telling you 0 to pi. So those are the bounds we're gonna integrate over 0 to pi, then the formula, 1/2 r squared. And then being able to type it in, 4.382. Anyone have issues getting that?
Free response questions for BC Calc are all 9 points each. So that's 3 of the 9. Part B, find the angle that corresponds to the point on the curve with the x-coordinate -2. What the heck is it asking for?
The angle that makes this, okay, I don't even have an equation for x. What is an equation for x? R cosine theta. Be careful to use the right thing. They gave you r and dr d theta, so r cosine theta. And again, this is the can you use your calculator? I would not be in polar mode, I would be in function mode. And calculator test, you need to show the setup of what you're doing. I need to see that. And then the mystery of the calculator comes in, and you can just say, here's my answer. So, algebra 2, pre-cal, you might have typed this into y1, this into y2, find where they intersect. And I kind of recommend squish it all to one side and find where does that hit 0. Because the number of times your calculator is centered with the x-axis in the middle, pretty much all the time, versus maybe these two things intersect outside your window. So let's see if we can type it in. Did anyone get an answer yet? Evie, what'd you get?
It's pretty low, though. I said 2.786.
2.786. All right, let's see. 2.786, yes. So let's see, parentheses, theta plus sine 2 theta. Don't be upset that they are x's. Close the parentheses on the angle as well as the trig function times cosine theta. Make sure to close the parentheses again. And then I'm doing the plus 2. Okay. I did something wrong. I missed another parentheses. And I should set my window 0 to pi only, so I'm not looking at all the other stuff. And then trace, second calc, where does it hit the 0? And this 83 is kind of a pain. Most of you have the 84s, which is better. Finally, I get the answer that Evie had like 5 minutes ago. Everybody okay with using whatever technology they have? And, yeah.
Should we do the other side? Because I think it hits 0 twice.
Let's see. It did hit 0 twice. Part B says, find the angle that corresponds. I would take the first one, but yeah, good point.
Isn't the other one out of the bound?
Well, I set my bound 0 to pi, and it doesn't specify.
I think the bounds were set up.
Oh. You're right. It says 2 pi. So now there should be only one. Okay. And this question, they're being all kinds of nice to you. They're telling you, all right, for pi over 3 to 2 pi over 3, drd theta is negative. We could have found that. It's just where 1 plus 2 cosine 2 theta equals 0 and then test things. But, okay. What does that say about R, and what does that say about the curve? I was very angry with this question the first time I did it. I saw that as one question, and it's 2. Yeah.
The R is getting smaller and the curve is getting closer to the pole.
DRT is negative, so the radius is getting smaller. Second question, what does that say about the curve? The curve is getting closer to the pole. Which is commonly known as the origin. There were two questions. I'm like, well, if the radius is getting shorter, of course the curve is coming, like. One point for information about R, 1 point for information about the curve. So that one, I don't know. It's different. Hopefully it's easy. You're like, I didn't even have to do math. I just had to understand that negative means things are getting lower or smaller, but something. All right, part D. Find the value from 0 to pi over 2, so not the whole thing. So that the point in the first quadrant has the greatest distance from the origin. What do I do? The distance from the origin is what equation? See that?
I was just gonna say that, we need to find the maximum
How do we find maxes in, a maximum of what?
of R. So
Of
you
R.
So you set like the derivative equation to 0 to find the critical points and then test it on R.
Okay, perfect. So, she says, what we want to maximize is radius. Distance from the origin is called radius. How do we find maxes and mins? We do the derivative. They did it for us. Then she says, find the critical points. So in there, where is that 0 or undefined? Okay, we'll get there in a second. We also need to check endpoints. All right, so when is dr d theta 0? Pi over 3. And then find your radiuses in each of those. Where's the radius biggest? And then we gotta make sure we're answering the question. Did it say find the angle or find the radius? Are we looking for when the biggest happened or what is the biggest? When? Find the value of theta. And to justify your answer, just a sec. They don't always accept a number line, and if you use a number line, you need to still put words to it. If you just say this and say the answer is pi over 3, you need words, because the dr d theta changed from positive to negative. Amelia?
How did you get?
Pi over
like,
3?
Yeah.
Okay. Theta said, when is the derivative 0? It's confusing when it's 2 theta, so I'm gonna just call it something else. When is cosine negative 1/2? Which they told us, actually. You told us these things. This one's up, oops. that one's out of the bounds from 0 to pi over 2, right? But it wasn't A. I want to know theta. Pi over 2. And you have a calculator. So you could just type it in and brute force and get the decimal. Okay, scary monsters, how are we feeling? So that's an example of a polar problem. We have like 3 minutes. Tomorrow in class, I have a matching thing that you need to match the graph to the equation to the problem for polar areas. Yeah, Sebastian.
Wait, is it possible for A and B to like combine this with like stuff from like chapter 7, or that doesn't really like quote?
That has been off the curriculum for over 20 years, but they used to make you find surface area of polar equations, so you would take a polar curve and spin it. It's kind of neat, but no. You do not need to spin polar curves. Thank you for your creativity. As far as I know, like, chapter 10, some concept on chapter 10 will be most likely in problem 1 or 2 on your free response. And I don't have the calendar up again. Oh. I know it's a little bit wrong. Did everyone get the calendar? Max, did you get a paper copy? So, you have another one, I have like 50. And again, the calendar part that's wrong is the MCAP testing week.
Great, I didn't save it. That's a bummer. So in
this week, please write it down. This part's wrong for you guys. You will be having the free response with calculator 1 and 2 on Monday, because we don't have class on Tuesday when it was scheduled. So first period doesn't meet on those days anymore. We do have mornings sort of open. If you guys have questions, you can come in like 1 at a time. The school starts here at like 11 or something. Yeah. All right. Yeah, tomorrow we'll practice more with polar areas of intersecting curves and stuff.